Hello, I've been meaning to do a somewhat short little review of these Growatts that I've now had in place since about March. So I bought these guys from Ian on eBay, two 3,000 watt Growatt model. I forget the model, I'll double check that. They're 3,000 watts each. They are configured in split phase, so 3,000 watts on this guy, 3,000 watts on this guy on each of the two phases. That gives you 6,000 watts combined for 240 volt, or 3,000 watts on each of the two phases. At this point, I've been running them, we're going on, I don't know, 5 months, I guess, at this point, and really have not had much in any way in issues with these units at all. I wanted to open up I opened up the bottom panel of this one so you can kind of see the wiring and stuff that's going on inside of here. So you got over on this side here, you've got your AC input and output. So this is your grid input and then your grid output for one half of the phase, and then the other unit is basically the same way, but that's the opposite phase going to it. So then these go back to your breaker panel. So what I have is I have a breaker from my main panel feeding these, and then these are coming down to a sub panel. That sub panel then supplies the majority of my everyday needs. We have about 2/3 of our lights in the house on this. I have our refrigerator. We have 3 chest freezers, my washer and dryer. My dryer is a gas dryer, so it's only using the electric for spinning the motor. We have a 18,000 BTU mini split AC unit on it, a 12,000 BTU mini split, and then we also have a little 5,000 watt window unit. So this is the front panel, and you can see right now we're on solar and battery. Battery's at about 53.4 volts. Fans right now, you may be able to hear them kind of ramping up. That's as the solar increases outside. The fans will ramp up as the load on the unit increases, both either in solar input or on draw on the unit. So if you're drawing a lot of power from your inverter, the fans will ramp up to keep things cool as well. Just kind of go through settings so you can see here's your input AC voltage, output AC voltage. Everything's pretty straightforward as far as this goes. There's your PV input. So I have about right around 3,000 watts of solar going into each of these two units. Each one has a I think it's 4,500 watt MPPT charge controller that's in there. And you can see right now this one here has about 1.7 kilowatts coming into it. I've disabled the annoying little beep on the menu on this particular unit, but I think it's still active on the other one, but that's just a menu setting that you can turn off. There's your battery voltage at that point. Here's your output. You can see right now I'm using about 25% of the load, or about 730 to 750 some watts are being consumed through that unit. So continuing on, go down here through your menus, and it's basically showing all your little stats. If you hold the enter button in, that takes you into the menus where you can program things. So I have mine set on SBU. That basically means what it's going to do is it's going to power things based on solar and battery, and then utility last. So as long as there's enough solar to keep everything charged up and the batteries stay above the voltage cutoff point that I've set in there, then it'll stay on solar and battery mode. If it drops below the low voltage limit that I've set for solar, that I've set for battery, then it'll switch back to the grid. The switch is pretty much instantaneous. It happens very, very seamlessly. I don't think I've ever even noticed anything flicker when doing it, and then it switches back and forth. The other modes that you've got through here, you can choose solar. Basically, in that mode, what it does is it will only switch to solar and battery as long as there is some solar being produced. It'll then stay there as long as it doesn't hit the low battery voltage. But as long as those two conditions are met, it'll stay on it. And then at sundown, when you're not generating any more solar, no matter what your battery level is, it'll switch back to the grid at that point. That's a handy mode if you want to preserve a certain amount of battery power in there above what you normally would, because then it'll basically, for a fact that it's going to switch back off the grid no matter what your battery level is at the end of it. But it's a unique mode, to say the least. So the UE1, that one there prioritizes grid first. That's basically more like the UPS type mode. Don't really use that one, but other people probably would. Going down through there, you've got your ability to set your limit for the amount of charge. I'll grab this little booklet so I can remember some of these things. Hold on. So this guy here, this allows you to basically set the maximum amount of amperage you want the charger to put in. This combines both the utility charger as well as the this also combines the solar. So there are certain modes that you can put this in where it'll charge the batteries from both your solar and your utility. So this is the total number of both of those sources combined. In addition, you can also set under another section how much you want coming from the grid to charge your batteries. If you decided you needed to charge it for that, like there's a storm coming up or something of that sort, and you want everything to be 100% full, you can then go in there and switch yourself to a mode where it's charging from those from utility in addition to your solar, so everything stays topped up. This guy here, this is the mode that I'm running it on. This is the default mode. It's basically the appliance mode. So in the case of this, you've got it basically allows it to run in the proper voltage range from 90 to 280 volts. This allows you to do your proper split phase. So this is the default mode that it comes in, and you pretty much want to stay in that mode. So this mode is called SDS. This is the saving mode disable. Basically what this allows it to do is you turn this mode on. If the load on the unit drops below a minimum amount, then it'll stop. It'll basically shut the inverters off, and then every so often it polls to check to see if there's enough load to turn the inverters on. Unless you're using this in an application where that would fit. Again, I've never had the need to use that mode. Now this is the battery type, and so you can see I've got this on use mode, which is user defined. User defined allows you to set your settings for lithium type chemistries versus your normal basic chemistry settings that it has in here is either AGM or flood. They also have a lithium section, but that is specifically for batteries that are designed to talk to this particular one with its little interface. That doesn't work with just general lithium. For anything custom, use your user defined, and then that allows you to set all your individual voltages. So in this guy here, this is the auto restart if overload. I have it in its default setting of disable. That way if something massively overloads the unit and it shuts it down, I can turn things back on, find out what caused it and make sure I don't damage anything, so it's not trying to just constantly cycle itself. This is the restart, and this is also set to disable. This is basically the auto restart if it gets too hot. Again, that allows me to make sure that if there's a major cooling issue or something of that sort, I can correct it so I'm not damaging the units. So So this is the output voltage, and your standard sections here is either 110 or 120. The default's 120. Of course, I have it set to 120 since this is in the US, and this is supplying 60 hertz split phase power. And so there's the 60 hertz setting, allowing it to show that. So this is the number of batteries connected in series, basically. I'm not quite exactly sure what this one really means or matters to the unit. There's not a whole lot of definition on here. I think currently it's basically kind of at its default. I believe it was set to. Changing this doesn't seem to make any real major difference. So now we're down to the maximum utility charging current. So again, you can set this up to a maximum of 30 amps. So it'll pull 30 amps per inverter from the grid. So a maximum of 60 amps max, 30 per. I have this set to 10, so that would be a maximum of 20 amps for the two of them combined to top off my batteries if I ever need to use this mode. So now we're getting into the battery voltage, the custom settings from that user defined. And so in the case of this, I have actually, this isn't the custom settings. This is the battery settings for when it switches back to the grid or when it switches away. So you have your low and high volt setting points. So this one here allows you to set when it would when it basically says, okay, the battery's at its low voltage state, go ahead and switch off and start using the grid. I have this set. I have a 48 volt battery bank, since these are the 48 volt Growatts, and I have this set to switch back to the grid when it hits 51 volts. That leaves me with about 40% of my capacity left in my batteries. I'm running lithium iron phosphate battery bank. So then if the power goes out in the middle of the night or something of that sort, I still have enough, juice left in the battery bank to cover things for a few hours. So I don't have to, suddenly wake up in the middle of the night to go shut off a bunch of things. I've still got some juice to keep things going for a little while. You can set the range on this thing from basically from 44 volts to 51.2. So you've got a range in there as to what you can set for when you want it. So if you wanted to set it to where it was basically at 0% for your battery bank, you could. I probably wouldn't do that, but that is, of course, up to you. So this is the setting point where you can set where it says, okay, the battery has enough charge in it that we can switch off of grid and start drawing from the battery. So in this case, I have mine set at 53. So at that point, it's got, normally by that point, my battery bank is up to about 65, 68% capacity. So it's charged up a fair bit, and it'll switch to that and then basically stay on batteries at that point until it hits that previous low voltage setting. And for this one here, you can basically set your settings from 48 volts to 58 volts, so you got a pretty wide range depending on your battery bank. My batteries are used lithium iron phosphate, so I keep mine in about a 54.5, 54.6 volts is the peak for topping off the charge. So this still gives me a pretty good range. So this here is the OSO setting. So this setting under here, you've got a few different choices. I have it on OSO, which means solar is the only source for charging the batteries right now. Now you can switch that, and I have switched that depending on if there's storms or other things of that sort coming through. And so you've got other modes. You go and hit your enter button and scroll through this, and you can see. So SNU is solar and utility. So that will charge from both the solar and the utility. It actually charges both simultaneously. So if you switch it into that mode, it doesn't matter how much solar or anything of that sort that you have coming in, it'll still use whatever you have under that utility setting to top things off to keep things full. This would be a good mode to be in if you're expecting major storms, because your batteries are going to be kept full the entire time. Your solar is obviously going to provide however much of the charge that it can, but utility is going to basically keep things topped off as well. Then you've got the CUE, so at this point it will charge, utility will be the first source for charging the batteries, and then solar would be the secondary source. Haven't really used this setting as far as it goes. In this particular mode, it only uses solar to charge the batteries if there's no utility available. So, you know, might be useful in a storm type situation, or prepping for a storm, but really haven't used it. And then this is the other mode, this is CSO. In this particular mode, it basically, what it does is it charges from your solar first, and then once there's no more solar, if the batteries still need charged, it charges from utility to basically, you know, keep things topped up. So if you got a good bit of solar during the day, you can charge during that, and then at night it'll top off on the utility to keep things basically full until you switch back to, you know, to things the next day. This mode here I find works pretty well with the other mode where it prioritizes running off on your solar and battery only when there's solar available, because at that point, once the sun goes down, you're automatically switching back to the grid at that point, so you're keeping your batteries topped up. Those two kind of combined together are pretty handy again for heading into some sort of storm situation. But I normally leave it on OSO, which is it only charges from solar, and then it does its thing. This one here is everyone's favorite button on these units if you've ever had to listen to that alarm. To give you an idea as to what I'm talking about, this is the other unit that still has it available, and every time you press the button you get that wonderful beep. Well, if you go into menu option 15 and you set it to instead of 60F, so basically off, and set it to off instead of on, which is the default, that one turns off the beep. So if it's on off, this is the default where the beep is on, and you want it on off, so you don't have to listen to that beep. So this guy here, this is the backlight control. The default is basically on, so if you had these things somewhere where I guess the backlight would be distracting, you can set that to off and it'll shut off the backlight when it's not being used. I have these things in office area. They're not super loud, but you know, I don't think you would want those fans in a living space, particularly when it's cycling up and down, because most people will probably find it slightly annoying just to listen to. It's fine here in my office area, but I wouldn't want this, you know, in say my bedroom. Again, this one just lets you turn off that backlight. So now we're over here to the alarm on and off. This one's beeps while the primary source is interrupted. This one here, basically, so if you were on grid and that source got interrupted, you'd get a beep. It doesn't last very long, but it is a nice little beep just to let you know, hey, something funky went on. This is the bypass disable. Right now that one is set to its default mode of bypasses, disable versus enable, and that's for the overload bypass. Basically, this says when it's enabled, the unit will transfer to line if an overload in the battery occurs. I don't have that enabled. My batteries can easily handle any of the load that's going to be on it. I don't really have any use for that setting for my application. So now we're getting down into charging. So this is where you set all of your charging parameters that since you're on a user-defined setting. So this is where you can set your different voltages. So in the case of this one, number 19, this is your bulk charging voltage. So depending on what value you need to charge your batteries up to, this is where you would set that. In the case of mine, since I'm keeping my batteries fairly conservative, I have my bulk charging set at 54.1. So basically it does its peak charging up through that point. The next setting is the float charge. I have mine set at 53.9, so it basically gets it to, you know, that 54.1, and then it dials back into this float arrangement, and basically keeps the batteries floated at that. This is your low voltage DC cutoff. So this is basically where you set, this is where you want to set, you know, this is the voltage you never want to exceed for your low battery voltage. So if you know that your batteries are down to say 10% capacity remaining when it hits whatever set voltage it is, and in the case of mine, about 47.5, leaves about 5 or 8% left in the battery. That's what you would set in here. If you're using some sort of custom batteries where, you know, it says set this as your low voltage cutoff, you could choose that as well. This is set in here. My battery BMS has its settings as well, so between the two of them, this should cut off before my BMS cuts off, and that should prevent the BMS from ever having to shut the batteries off from the unit. So you definitely want this higher than whatever your BMS is set point is. Down here you've got your setting for the solar power balance. The default is to have this enabled, and basically it gives you a couple of different things here. Basically in the balance, it's going to adjust the solar input to the max, to use the maximum amount of whatever you can to charge your batteries as well as run your loads. In the other mode where it's disabled, the solar input is basically just set to max, to the max charging load. So your solar, it's going to bring in basically as much solar as it needs to keep the batteries charged, but it's not going to dynamically shift as much. I've just left this at the default, and I've never had any issues with it. I really haven't played much with the other option, but there might be a use case for it for somebody else out there. So in this guy here, this is where you set the AC output mode. And so you'll see, oh, actually, I think we skipped one. Yep, we did. So, never mind. I forgot about this. So you notice it jumped from 22 to 24. There's actually an option in between here that's in 23. 23 you can't set while the inverters are on. Let me show you that again. So I think I had the little camera pointing in the wrong direction. But you'll see this says SBE 22, and so that's where I was talking about that solar balance. And it jumps over here to this number 24. 24 basically is telling you the neutral and grounding of it, of the AC, neutral and grounding of AC output is disconnected. This is basically your default setting. Again, this is going to depend on the grounding setup that you have for your particular setup. But the reason that you notice that it skips over those two numbers, 22 and 24, is that number 23 is where you set the power output of these things. So if you have multiple units paralleled together, or if you have them set up in split phase mode, that's where you set the settings for that. And so there are the different phases that you can choose under 23. Obviously, if you change that while it was on, very bad things could happen to all of your electronics. So they only actually let you change that when the inverter is off. Under that particular mode, you have the settings where you can set this to either 3-phase or split phase. Split phase, you have 2P0, 2P1, and 2P2. 2P0 is for inverters connected to the L1 split phase. So you would set one of the units to 2P0, and you set your second unit to 2P2 or 2P1. So in the case of this, one of these guys is set to 2P0 and the other guy is set to 2P1, and that basically says that this unit is first phase and this unit is the second phase, or vice versa. And then you can also, if you had additional units, so as you can expand this beyond just 2 units, you can have 3 units or you can have 4 units. So instead, if I had 2P0 and I have 2P1, You can also then go over here and set another, if you added an additional inverter. Let's say you have a bunch of 120 volt loads, but you don't have that many 240 volt loads. If you set that up, you can add an additional inverter on that one particular phase, so that would give you 2 inverters, 6,000 watts on that one phase, the 3,000 watts on the other phase, or 6,000 watts with those 2 inverters combined with that additional 3,000 watts on that one phase. Alternately, you could put in 4 of these. So if you put in 4 of these, you'd have 3,000 watts per inverter on each phase. So that would give you 6,000 watts on phase 1, 6,000 watts on phase 2. But that's where you set those settings. And again, you can only set that while it's off. That way that you can make sure that you set it correctly. And I highly, highly, highly recommend that after you set those settings, you have all of your loads that may be connected to this thing shut off. So in the case of this output goes to my little sub panel. Everything in that sub panel will be shut off before you do any settings. So you shut everything off, set your settings, turn the inverter on, go to that panel, make sure that you have proper split phase power coming in, that it's showing up on through that thing before you turn anything back on. That way you don't run the risk of damaging anything or anything of that sort. So down inside of here, in addition, this is this little control board. This has the USB inputs that plug into this guy. You've got over here, this is where you've got your solar coming in. You've also got so this is your battery connections. Those are the further ones back there. That's your battery in the back. Everything at the bottom, if you actually look underneath here, you can see everything is clearly labeled. So there's your on-off switch. There's your DC input. This is your PV input. You've got some dip switches that can be set down here as well. Actually, I believe those are your connections that you can connect up to trigger things like a generator auto start. And then you see this little guy here that says Growatt on it. So this is the Shine USB module, and I'll show you guys that in a little bit. But that basically lets you monitor this thing either through an app on your phone or through a website on the web, where you can see all of the data that this guy produces in a day. And it logs the data every 5 minutes. Now, one of the things, since I was one of the first guys to get these units in, initially I bought the 2 units, and I bought one of these modules because we thought, well, once these data cables that link them together, once they're connected up, they're talking to each other. With the one module in there, it should see all the data from both of them. But that's not actually how these guys work. In the case of this, you actually have to have one of these modules for each individual unit. Otherwise, you cannot see the data from the second inverter in the app. Basically, you plug this little guy into it. There's a USB port that's down here. There's a couple little screws that you can screw the thing in. I actually don't have the screws in there. They stay in place just fine as is. If you were in a road going application or something with vibration, you'd probably want to screw them in, but in my case they don't. And the reason I don't have those screws in there is that on probably, I think I've had it happen about twice at this point. There's been a couple of times where, for whatever reason, the modules have basically just stopped logging data. If something happened with the internet connection or whatever, but pull the module out, wait about 10 seconds, plug the module back in, boom, everything's back up and running. They're pretty easy to add. There's a little barcode and stuff that's on the back of it. So if you have the Growatt app on your phone, it's got a little QR code where you can literally just hold the thing over it. It'll add it to the app and it'll join it. And you can set up all your parameters and stuff on there. But in the split phase parallel mode, you've got these 2 cables. The cables come with it, so you don't have to worry about getting additional cables, and they link this together. And so in the case of this, for split phase mode, this guy here, the way these cables work is this cable that's on port 2 comes over here and connects to port 1 on the second unit. And then from this unit, you have port 2 comes back over here and connects over to port 1. And that's how you connect two of these guys together for split phase. It lists out all the little things in the booklet as far as how to connect these guys together. It's really straightforward. I didn't really have much in the way of any issues as far as that goes. The only issue I had initially was I connected up all the wiring, went to turn these guys on, and one of them was saying it had an error, and come to find out the dual pole split phase breaker in my panel, one of the two wires was actually not seated all the way in there. So one of the units was getting AC power, the other unit was not. It was recognizing that, hey, I'm configured for split phase power, but I'm not seeing split phase, so there's an error, and so it would throw up an error code saying, hey, this is not right. It took me a little while to figure that out, and it was literally, oh, there's a loose connection on this breaker. Once I fixed that, boom, everybody powered up, and it's been running fine ever since. In my little setup here, I have, like I said, these guys here. I have a smaller little 375 watt inverter. This one is directly attached to my battery bank, and this covers the lights in about three of the major rooms we use on a regular basis. That way I have lights that still work even if I have to shut off these inverters to do any kind of maintenance or anything of that sort. I still have my overhead lights, and that's completely separate of everything else. One other thing I just wanted to kind of go over as well for those of you that are not quite 100% familiar with split phase. So you're looking at this guy here, and let's see, so yeah, so right up here, this is the input. The front ones are the input. The back one back there, that's your output. I'm not quite sure why they put the output to the back and the input to the front, but you know, it is what it is. So what you've got here is you've got your ground, you have your line, you have your neutral. Now remember, in split phase, neutral is the same for both phases. So you have a common neutral, and then you have line for phase 1 and you have a line for phase 2. So this neutral here is the same neutral on both inverters. So that inverter over there, so your neutral on this one and this one go to the same neutral source. Then your lines are the separate lines that are coming back to that. So you know, depending on what cabling, etc., that you use for this, the wiring that I'm using is rated for the load that these guys can put out. You can put larger diameter cabling into these things. I forget exactly how big of a cable they can handle, but I know it'll handle a little bit larger than what I currently have going into these guys right now. But that's something you want to, you know, keep in mind when you're wiring this thing up, that you know, you're going to have you know, neutral to these two. So in the case of this, I have this little box down here that basically everything is kind of coming down into, etc. You know, this is not the cleanest setup, I'll admit. This is, you know, and some of this I'm going to go back and do a little bit of changing around and stuff, because again, I put this system in, I wasn't exactly sure, you know, how well this system would work, etc., because you know, it's pretty new. Now it's been using it, been very happy with it. I'm probably going to come back and replace some of these things with some more permanent type solutions, but I mean, everything here is, you know, sealed off, secure. There's no real issues with it, etc. But like, you know, some of these lines like this, I'm going to reroute these things around so things aren't underneath each other, that sort of thing. But I just wanted you guys to be familiar with that in case you haven't dealt with split phase power before. You know, that's something you definitely want to be familiar with. If you don't know what you're doing, talk to an electrician. It definitely can't hurt you, and it's better to be safe than sorry.